Well, welcome to the latest video. I guess this is part 8 of the impregnable flywheel saga. So yeah, the impregnable flywheel saga, and I have now got another plan. So I think at the moment the score is flywheel 4, Avian 0. So I tend to try. Probably not going to even that score up, but I've got to win once at least. So the plan is to drill this with 2 bolts and use part of a puller. So we bought these bolts from K-Fast, who are in Wakefield. So there they are, just there. So the original idea for this was to use a couple of bolts, M6 bolts, and the only one I had was these. These are a pitch of 1.25, but the only tap that I've got is a pitch of 1. So I had to order some specially from K-Fast, who supplied me with these. So this is the puller. You can see it's like a bar with a slot in it, and the original puller parts, they go through like that, which gives me a further option. Because essentially what I can do is, if these bolts snap, then what I can do is I can get some M8s. You can't really get M7s, so get some M8s and file flats onto them. These actually go in, but I can file flats onto them like that, and then use a slightly stronger M8 to try and pull it. So I've got like a let's say plan number 7 if this doesn't work. So the plan is to get these M6s into the puller like this, drill 2 holes in the flywheel, and then try and pull it off that way. So there you go, 2 very neat punch marks opposite each other, and it does seem, you probably can't see that on the video, but it does seem that there is a space under here. So when we drill it, we know we're not going to hit any coils or anything like that. So I've drilled that out to 3mm by hand, and I was just looking on the internet. The tap drill size for 6mm times 1, which is the course, is 5mm, so I've only got to go 5mm on this. Okay, so that's us drilled out to M6, well M5, which is the tap drill size for M6. So now I need to do tapping and hope this works. So, there we go. So it looks like the nuts are fitting. So as you can see, they are a little bit wonky, and this is because I drilled them by hand. So we are pretty much there really. So I'll try and get this as straight as we can get it. That's about 18. And that's about, just a little bit off. So this is Imperial, and I do not have a socket for it, I'm afraid. Oh, it's resisting me. Come on, come off. Well, something snapped. Did it come up? Yay! Ha ha! We got it off! Very, very good Chinese bolts, folks. Top job to the Chinese engineers. The big reveal. Oh, look at this, the big reveal. Oh, I can't believe that. Off she comes. Wow, there you go. Set points. So now we can service the points and test the coils, make sure they're okay. And it doesn't look like we've got any cracked magnets or anything like that, so fantastic. That has taken so long. Wow. Okay, so these are the bolts. There is no damage to those, so they are very, very strong. But look what it did to the washers. That must have been some pressure. So there's our points for the job. Couple of condensers look different. Don't know if that's right or not. Yeah. They look in great condition, do they? So here we go. We've had a look at this. Point sets. Cleaned up all the contacts. The coils do seem to test okay. And only one of these is actually used for the ignition. It's that one. So this had circlips missing. I don't actually have any, so I've put a couple of O-rings on top of it. They don't generally come off those though. So you can see the points now need to be put. The whole flywheel needs to be put back on now, and the points need to be adjusted. And then we can start testing whether we've got spark or not. So what we've got here, these wire from either side of the coil here come out to the spark plugs, to the coils that go to the spark plugs. And you may be thinking, well, why is there two wires there? Well, there's two wires there because the way the kill switch works is one of these wires goes to one plug and one goes to the other plug. And basically what happens is the two plugs are shorted together. That's how the kill switch works. Right, so this is the underside of the flywheel. You can see the two holes there where we drilled to get the tap thing to come off, and there's the magnets seem to be okay. So what you can see there is the slightly off centre ring in the middle there. That is actually the cam which drives the 2 points to open and close. So essentially you can't set the points until this is back on again. Okay, so I've been through all the wiring on the top of the motor. And there's a sort of real estate diagram, and I've went through basically all the connections and tried to work out what was what had what ohmage and so on. So this is the final diagram that we managed to work out. So the second coil, the one on the other side, which is that one there, this second coil does not appear to do anything on this engine. It comes out to the front of the engine on 2 pins like that, and likely it's designed to power a periphery of some kind, maybe the running lights of the boat, or perhaps a fuel pump. So you can just see there that goes to ground, which is just there, and then this one here comes back up and attaches to that wire there on the coil, and the other end is silver soldered to the steel. So I very quickly came to the conclusion that the second coil is nothing to do with the points, nothing to do with the ignition at all. So this is a twin cylinder motor, so you've got 2 sets of points rather than 1, and you basically just, because the engine is rotating all the time, you can just treat that as a generator. So essentially you've got your condenser there, and the points essentially connect and they put energy into this coil. There's about 40,000 windings in the top part of the coil, and this is called an auto transformer because it only has the one actual coil. And when those points release, basically that point there is then grounded, and this massive amount of energy that's stored in this 40,000 windings at the top here ends up across the spark plug, which is there. And then obviously you've got the little cam which we just showed you. There you go, that cam there is then making one set of points open, and then the other, and then the other, and then the other, and then the other, in order to get the pistons to fire. It's a 2-stroke engine, so they're probably arranged to be firing one after the other. That's pretty much how it normally works anyway. And so the other side works exactly the same way. So the kill switch is connected to this point here and this point here, and it comes up and it just has a switch which shorts the two together. So I go back, there you go, there's the same, that point there and that point there, which is the same point, and the kill switch just sits in the middle there like that. So that's how the electrics actually work. And I've been through most things on these, and everything seems to be pretty good. We just got to test the coils properly. I think they tested out okay last time I looked at them though. And the only thing I can't really test is the condensers. So I can put the multimeter onto these and I can get a rough idea if they're working or not, because you see them sort of charging a bit and they're not shorted out. So they are probably good. In actual fact, they're probably rolled paper capacitors and they're sealed, so they're probably still good for 100 years really. So we're about ready to assemble the parts for the ignition system and check and see if we've got spark or not. As far as ignition timing goes, I do not see any ignition timing marks. There are none on the wheel here, the flywheel. There's nothing on the rim. The only possible reference point that I can see is the little Woodruff key just there. So I think we're probably going to have to wing it. Well, to wing it, you can see here there's a slot and a screw, and there's a slot and a screw there. So you clearly can adjust the timing, and that's very interesting. So what I'm going to do is I'm going to try and work out where top dead center on this is, because if you look on the casing here, I don't see any little arrows or anything like that that would, you know, reference something. So that's a tough one. We don't have the handbook for this motor either. Unfortunately, it's very old, and I think they are popular in Europe, but they're not so common in this country. So yeah, tricky one. So obviously there are not going to be any marks inside because you wouldn't be able to see them. So yeah, that's very interesting. So I think to get top dead center, you would normally use something like a clock gauge like this, right? So to do that I would have to make an adapter, and right at the moment I don't really want to bother doing that. I don't actually have a spare spark plug kicking around to do that right now, so what I'm going to do is just do something simple like sticking a felt tip pen down there. So I'm going to mark this just so that I can see what's going on, really. So we're going in, low point in the cycle. And there's a little dead spot just there, which I think is the bottom. So I just put a mark on there, and then it seems to stop moving about there. I think that's pretty close, actually. And then it hits a dead spot about there, and then it starts to go down about there. So I think TDC is in that little window just there. Okay, so this is not particularly scientific, but we're basically going around with a pen, and you can see the area there where the pen just doesn't move, and then when you move outside of it the pen moves, and move outside of it the pen moves the other way. So pretty sure that's top dead center. Also just marked off, just for reference, where the bottom dead center is, which is also there. So now what I'm going to try and do is mark off the flywheel here, and then mark it off in degrees, and then try and get the, if you Google this, essentially it says that a small two-stroke should have a 0.3 to 0.38 millimeter spark gap and 16 to 35 degrees timing advance. So we need the points to open about 15-16 degrees before TDC, which is in that direction because it rotates that way. Okay, so I'm back on the bench, and I'm going to mark at TDC and I'm going to mark at BDC. So I need to somehow get halfway in between, which I'm going to use these dividers to do. That's pretty close. So I need to just make a mark and then work out where the centre is. And I'm just going to check with the other side, and we'll make sure that the marks are pretty similar distance apart, and then we know we've kind of got it roughly correct. So I'll just measure that. Pretty good actually. Yeah, they're pretty close. As I remember, 45 divided by 3 is 15, so we need to divide this into 3, which is a touch more difficult but not too bad. Right, so we'll mark this off now. We've got 3 marks here before TDC. That's your 45 degree. That's your, well, that'll be 30 degrees. And there you go, here's your 15 degree mark and your TDC mark. So that's about, you know, with these sort of crude methods that I've got here, it's about as accurate as I can really get. Okay, see, we've got a timing mark there now, which you can look directly down on over the flywheel. And if you come up, we've got a timing mark and a 15 degree mark. Okay, so initially I mark this off and it goes in that direction. When you pull the pull start, it goes in that direction. And there's also an arrow put on by the manufacturers, which is about the only marking they have put on there. So what that means is that TDC here spins in that direction. We want 15 degrees before TDC, not after TDC, so I just need to mark it there instead. So I've done it slightly wrong, but we'll get there eventually. Okay, coming back to the circuit diagram. So the generator coil, if we disconnect one side of it and then put a buzzer onto there, when the points close it'll buzz, and when they open it'll stop. So that should, and this will be out of the equation because we take one side of it off, so we should be able to work out when the points are opening. This wire here goes to the points. This is the insulated part of the points, which goes to the arm of the points. Right. If you look closely at a set of points, you can actually see the plastic inserts where it insulates away. This wire here goes to one of these, probably, I'm not sure exactly which one, but probably one of those. And this is a condenser, so I'd rather not have the condenser in there, but it provides a convenient connecting point. Just there, I don't know if you can see that. No, I'll maybe put the back camera over that in a minute, but there's a special slot there for a screwdriver so that you can wiggle them back and forth to get the gap correct, which is probably going to have to be the next job. So according to Google, the gap should be 0.3 to 0.38 millimeters. That's what Google says. Google AI. So this is the game whereby we stick a feeler gauge in there and we try and get it to about the same size as the gap as that gauge. It's a bit slack right now, so they're made of steel and they've been there a while, so a bit like the Blues Brothers. I'll try to do that next video, so thanks so much for watching, folks.